Okay, here's the second book problem. So we've got this construction for a parabola. So let's just take the point S that's supposedly on our parabola. So we've got to find things in terms of the parabola. So we see that the ordinate is SS prime and the abscissa is ds prime. And kind of like the given data that we have is dq and qp, because that's what the axes that we start off with. Okay, so we have similar triangles, and we see that SA prime on A prime P is going to be the same as AQ on QP. Okay, so that's what we've got to work with. So SA prime, let's bring it over to the axis. So that's the same thing as S prime Q, and that's the same thing as DQ minus ds prime. Okay, that's good. That gets us the abscissa and things. A prime P on the bottom there, well, we can write that as QP plus A prime Q, and A prime Q is the same as the ordinate. So that's QP plus SS prime. Okay, so that's good. So that gives us that the first relationship there, ratio that we have there, we can put that in terms of information that we need to use. Okay, so let's work on the ratio AQ over QP. So AQ is equal to DQ minus DA. And so that's there on the vertical axis. Let's transfer that to the horizontal axis, and we can do that. It's kind of equivalent to RQ minus A prime Q, right? But we multiply it by DQ over RQ. And this is taking account for the fact that we've cut up DQ into equal number of spaces as we have with RQ. Okay, so DQ over RQ is is like the scaling factor that goes from the horizontal axis, the vertical axis to the horizontal axis. Okay, and let's then just put this all in terms that we want. So instead of RQ, let's put it as QP. And instead of A prime Q, let's put that as SS prime. And DQ, and instead of RQ, we'll have PQ. Okay, and so then that means that AQ over QP up here is equal to QP minus SS prime times DQ over PQ squared, because we've divided it down by another amount. And so this is equal to this side over here, which is equal to, what is it, DQ minus DS prime over QP plus SS prime. Okay, so we've put it in terms of everything that either the ordinate, the abscissa, or the given stuff. And now we can just cross multiply Let's do that down here. So we get QP minus SS prime times QP plus SS prime equals QP squared on DQ times DQ minus DS prime. Okay, and on the left-hand side, that's just QP squared minus SS squared. And then multiply this out, we get QP squared. So these guys cancel out. And what's this? We get minus QP squared divided by DQ times DS prime. Get rid of the minuses. And what have we got? We have got the ordinate squared equals QP squared on DQ times the abscissa, but QP squared on DQ is just a constant, right? It's didn't depend upon which point S we did. So if we did a different point down here, we would still get the ordinate squared equals that constant, that parameter times the abscissa. So that means we have a parabola and this QP squared on DQ. That is the latus rectum of our parabola.